Hey everyone, today I'm going to show you an overview of how you can use the new Claude 3.5 Sonnet AI in Python. We'll take a look at things like basic chat examples, how to use custom tools via Claude, and how to use it for vision or image related tasks. In case you're not familiar with what this is, Claude 3.5 Sonnet is the latest and best performing LLM model from Anthropic. At the current time of this recording, it's also the best performing model on multiple benchmarks, including writing code and processing images. If you haven't used it yet, I recommend you going to their website to try it out. It works with text and vision. Here's what the console UI looks like. There's also this new feature called artifacts, which lets Claude store its output, for example, code and text, as separate files. And this will be separate from the chat window itself. And I find it a really nice touch that the artifacts window acts as both a code editor and a preview window. So this will let us do some pretty incredible things. For example, we can drag and drop a screenshot of a website, and we can ask Claude to implement this in React. So my prompt here is to generate a one-page React app based on this example. And I've also given it additional styling instructions. It will then generate the code for that as a file, which we can copy or download. But there's also a preview tab, so we can actually open this preview tab and it will render the page for us, and we'll be able to interact with it in real time as well. Now, this UI is a great experience, but if you want to use Claude as part of your own project or product, you'll of course need to use the API. So that's what we're going to go over here in this video. First, we're going to learn how to make basic API calls in Python. This will allow us to use Claude from our Python code, and it's really easy as well. Then I'll show you how to create tools for Claude to use. These are basically custom functions that Claude can generate inputs for. In this project, we'll create some tools to let Claude read and write text files into a local folder. We can then ask Claude to write some Python programs for us and save that into the folder. And then later on, we can also ask it to read the contents of the folder and write a unit test for that program. Then, if I go to my artifacts file, I can see that these programs Claude has written are really there, and I can even run them. Finally, I'll also show you how to use Claude's vision capabilities via API. We can use it to read a screenshot of this pricing table for a cloud service, and then use the information gained from that to calculate the cost of using the service for 1,000 users. Now, these are all quite simple examples, but I think they'll help you understand how it all works and give you an idea for how you could implement a more complex project using this technology. This is not going to be a deep hands-on coding tutorial though. The purpose of this video is to give you an overall idea of what you can do. But having said that, the code is all there and it does work. So if you want to run any of this for yourself or just follow along with the code, then you'll find the links to this GitHub project in the video description. All right, let's get started. First, let's start by setting up our project environment to use the Claude SDK in Python. For the purpose of this video, I'm going to assume you are familiar with Python and Python environments. Create a requirements.txt file in your project root directory. Here are the current versions of the libraries I'm using. The Anthropic package is the official Anthropic Python SDK for interacting with Claude or Claude 3.5 Sonnet. And we'll use PyTest for the unit test that we will generate later. You can then run this command to install the packages. Next, we'll need to set up our API key. So if you haven't set up your Anthropic account already, go to this website. Once you're on the website, go to this Build with Claude API link over here and click that to go to the Claude console. And here you might need to sign up or create an account. And once you do that, you can get your API keys from here. So click that and then click create a new key. Now for this video, I've already made one. To be able to use your key, I also think you need to add some credits. So you might need to upgrade your plan to at least the build plan, which I believe is the lowest tier. And then you can just add some credits. So it doesn't have to be a lot. You can add $20 or something. I think that you can also claim some free credits at the start. So you might not actually need to spend any money at all. And just to give you an idea of how much it costs, it's actually really little. I've been using this thing for the tutorials and just for experimentation, and so far it's only cost 5 cents. Once you have the API key, I recommend setting it as an environment variable. And here's the bash command for Mac and Linux. Alternatively, you could also just set it up when you initialize the client. But I don't recommend this because then your API key will be exposed in your source code. All right, now we're ready to start with a basic Hello World example. First, you can create an API client like this. Remember, you need to set your API key into the environment variable for this to work. Here is what a simple API call looks like. Let's go through the parameters really quickly. The most important thing is the model. Here, we're using the model Claude 3.5 Sonnet, and you can change that to a different model ID if you want to use something different. But currently, this is the best one. The max token and the temperature attributes are pretty standard LLM parameters. The max token attribute lets you control the maximum token length of the response, and this has a direct relationship to the API cost. The temperature attribute helps you control the randomness of the response. I have the temperature at 0 here because I want the responses to be more consistent. But this value ranges all the way from 0 to 1. So if you want it to be quite random, you can max it out. Next is the system prompt. This will set the context for Claude's responses. It's also one of the best ways to influence the tone, content, and structure of the responses you'll get from Claude. And finally, you have the messages parameter, which is going to be the actual query. And this is a list of message objects. Each message object is going to be a dictionary with a role and a content. The role can either be user or assistant, and the content is a list of objects. Each content object can then represent things like text or images. In this example, it's just the content for a single text string. Now, if you're following along with the GitHub project and you want to run this, then here's what the project looks like in our code editor. All the code that you just saw is in this file called claudequickstart.py. So here you can see that we're importing the library and then we're creating the client, and this is how we set up the message. And then we can read the response by printing out the message's content. So I'm going to open up my integrated terminal and then just run the script. And here, this is what the response looks like. So it's answered our question and it's followed our instruction from the system prompt as well. And remember, if you're going to run this, you will need to have your API key set in the environment variable. Otherwise, you can also pass it into here when you first initialize the client. Next, I want to show you how to create and use custom tools with Claude. This is an extremely powerful feature because it enables your LLM to observe and interact with the real world. You can think of tools as arbitrary Python functions that we can create. And these functions can do anything we want, such as checking the weather or sending an email. We can tell Claude about what functions or tools are available, and then when we want to use them, Claude will give us the inputs and the name of the tool that it wishes to use. So for example, let's say I had a function like this to get the weather for a specific location. Now I want to be able to tell Claude about this function, such as what's the name of the function, when to use it, and what input parameters it should accept. So to do that, I can convert this function into a JSON schema so that Claude will understand. And here's what that would look like. Then when we want to call the API, we can tell Claude about this tool by passing in these schema objects as a list, and we can pass it in by using this tools parameter when we send a message. When Claude receives this message, it will first need to decide which tool it should use, or whether it even needs to use a tool at all. You can also force it to use specific tools as well by changing this type parameter. If Claude does decide to use a tool, it will respond with a JSON object like this. This is the input it wants to send to our tool. Now, Claude doesn't have the ability to call our tool or our function directly. That's something that we control, and we'll have to implement that on our end. So let me explain how this works really quickly. When we send a user message to Claude, we'll put it into a list of messages. First of all, that's because LLMs are stateless, so we'll need this list to act as a kind of memory of the chat. We'll also pass it the schema of each of our tools as well. Now, when Claude processes this message, it will need to decide whether or not to use one of these tools. If the answer is no, then it just responds with a chat message, similar to what would happen if we didn't have any tools at all. If the answer is yes, Claude will tell us about which tool it wants to call and what input parameters it wants to use. So we can take Claude's response here and call our tool with those input parameters by ourselves. Then we can choose to use that result directly, or we can send it back to Claude as the next step of our conversation. We can do that by updating our messages list with the output of the tool and then repeating this whole process again. Okay, so now you know how tools work. Now let's create our own set of tools. Remember how in the web UI version of Claude, I have this artifact window on the side? Well, it turns out that at the time of recording this feature isn't available in the API yet. So I wonder if we can implement it ourselves by using custom tools. Now, just a slight heads up here, I am planning to go through all of this code very quickly because as I mentioned at the beginning, I intend this video to be more of an overview than a step-by-step coding walkthrough. But you can always refer to the GitHub project or just ask me in the comments directly if you want to go a little bit deeper or if you get stuck. Okay, so here are the function signatures I want to implement. There's 3 functions, and I will hard code an artifacts folder that I want Claude to be able to save files into. I also want it to be able to load files from it and list which files are available in that folder. This way, we can sort of have our own bootleg version of the artifacts feature, at least until Claude implements it officially. Here's an example implementation of one of these functions. It's pretty standard, just a simple function to write text into a file. Now, we'll have to create a JSON schema for each of these functions, and it needs to look something like this. You could do this by hand if you want, but there's an easier way. I found it really easy to just paste all of my functions into Claude along with an example schema. Now, you can just ask it to generate the schema for each of the tools, and it does a fantastic job at this. It even saves them as separate artifacts. We can just go ahead and copy it or download it. In my project, I created a folder called tool schema, and I've saved each of these schemas as a separate JSON file. Now, once we have the JSON schemas for our tools, we're ready to integrate them with Claude. Once we've integrated these tools with our app, Claude will be able to save, load, and list files within our artifacts folder. That will give us the possibility to do things like create new files, analyze files, or even create unit tests for Python code in those files. If you want to follow along with this specific chapter in code, then I recommend you just make sure that you have this tools.py file configured properly. I've added a couple of utility functions and just done a bit of additional setup in addition to the core logic that we've walked through in this video. So just have a read of all of this stuff and make sure that it makes sense to you before you get started. And also make sure that you have each of these JSON files in the tool schema folder here as well. Now, when we're using tools, we actually might need to send multiple messages or different kinds of messages. It's no longer just a single one-off message. So we're going to wrap the entire message calling function into a separate function so that we can reuse it. There are 2 main things to take note of here as well. The first is that we've passed in all of our tool schema objects as a list. The second thing is that we need to keep a list of all the previous messages we've sent to this LLM because, as I said before, LLMs are stateless. So anytime we want to have a chat-like experience or we need a chain of thought reasoning that needs multiple steps in the thought process, we need to send it the entire history of the chat. Now, after we call Claude with our tool, we will receive a response. And we can check if Claude would like to use one of those tools. So first, we can check this stop reason attribute of the response for that. If we need to use a tool, we can just unpack the input parameters and execute that tool with those parameters. Then, with the output of the tool, we might already have the result we need. For example, if we ask for the weather or the temperature, the information that the tool returns is pretty much the answer that we wanted. Otherwise, if it's something like this where we want to save files or read files from a folder and then do something additional with that information, we might want the conversation to continue. In that case, we can turn the output here into a tool result message and then send that back to Claude again, along with the rest of our message history, of course. Some of you might have noticed by now that this is indeed a recursive execution of this send message operation. So you might want to design some safeguards around this just to prevent infinite looping or runaway API costs. Now, before we test our app, I'm just going to wrap this entire send message block into an even simpler one for just when we want to send plain text messages. This way, at the application level, I have a very simple abstraction for when I want to just send a simple query like this one. Here, I'm going to ask it to write me a Python program that can add 2 numbers together, and it will save that to our artifacts folder as add.py. So let's go back to our project to try this out. Here is my program that I showed you earlier, and this is all of it put together. And here's the actual message I want to send. So write me a Python program that adds 2 numbers together. And I'm giving it my tools. So here's a list of all the tools. I've saved this as a constant. And my artifacts file in my project right now is completely empty. So let's open our integrated terminal and run this program. Okay, let's take a look at the output. First, I get this system response. It says, yes, I can do this for you. And then I've also asked it to explain the reasoning so that I can debug it more easily. Here, it actually chooses to use this tool called save artifact. And the output is that this is saved successfully as add.py. And then the system responds again saying that this was successful. And then it uses the list artifacts tool to confirm that the file is actually there. Now let's go into our folder and we can actually see the file has been written there. And if I click it, it looks like it's a valid Python file. Okay, now let's go a little bit further and make sure that we can actually load artifacts and do things with whatever's in this folder as well. So here, I'm going to change my message a little bit. So here my prompt says, write a simple happy case unit test using PyTest for every Python file in this artifacts folder, and then save them as test underscore whatever it is .py. Now I can actually be kind of cheeky and create a manual file in there myself. So for example, let's create a multiply. Okay, so I've created a new file, and this is not the same one that Claude created for me, but they both exist in this file now. And my instruction is to actually create a unit test for each of the files. So let's see what happens when we ask it to run that. So now it's finished, and you can see that it's actually sent several messages while it was processing this command. It first listed all the files in this artifacts folder, and it saw that there were 2 files. So it's processed each of these one by one. First, it did the addition file, and it gave us a unit test for that, and then it did the multiply file. And I can actually see that these new files have been created in this artifacts folder. So here's one unit test here, and here's the second unit test. Let's go ahead and run this unit test and see if it even works. And yes, it does work. So you can see that test add and test multiply were both run, and the test did pass. The final feature we're going to take a look at today is the vision, or the image processing feature. This allows us to send images to Claude via API and then use it as part of our prompt. There's a lot of use cases for this. For example, you already saw earlier how we could just drag and drop a screenshot of a web page and then ask Claude to replicate that for us. But I also found it really effective at analyzing pictures of data. For example, charts or graphs. For example, here, I can pass along an image of the pricing table for AWS Lambda Serverless Compute. I work a lot with AWS Lambda, and sometimes I want it to be a little bit easier to calculate pricing for an idea that I have if I were to make it live. Now, an idea I have for using Claude is to ask it to interpret this image and then even help me work out the cost of different usage scenarios. So I wanted to output something like this. Now let's walk through the code needed to do that. First, we'll have to load the image from disk. That's if it's a local image that you want to use. Or we could also load it from our URL as well. Then we'll need to encode it in base64 because that's the format we'll need if we want to send it to Claude. So this snippet shows you how to both load it from disk and also encode it to base64. Next, we'll probably want to send a prompt along with this image to tell Claude what we want it to do with the image. Here's a prompt telling it that I want to model the usage cost of AWS Lambda under the following circumstances. It's going to take the information from my prompt, the pricing information from the image, and then use that together. When we want to send the image to Claude, we'll also need the type of the image and the image data itself encoded as base64. So here's how that will look using a PNG image and the helper function that we created earlier. Then all you have to do is just call Claude's API, like the same one that we used before, except that you pass in all of that information as a content block. Here's the full code for making that call. Now let's go back to our editor and try it out. So here is the vision example file, and here's all of the code that we saw just now. So it's all here, and my image is going to be this Lambda pricing table. It's just a screenshot, and I have it in my images directory here. So let's go ahead and open our integrate terminal and run that. And this one does take a while, firstly because we have to send it the entire image and there's quite a few steps of the process, but it's created the pricing table for me in Markdown, so it's understood the information, and then we use this information to create a cost projection for 1,000 users, 10,000 users, etc. Now, I actually haven't done the verification to make sure that these calculations are accurate. That's probably something I'd want to follow up with. But this just shows you the capability of being able to use an LLM with an image and get some kind of interesting output out of that. So we just went over a couple of fun examples for how you can use the Claude API in Python. Now, in this video, I was focused on giving you a higher level overview of what you can do, but the full code for this project is available on GitHub as well. Just follow this link. So if you want to take a closer look or even run this for yourself, you can download the code and use the programs yourself. And if you want to dive deeper into any of these topics, for example, calling custom tools, image processing, or even building a fully fledged AI agent, then let me know in the comments whether you'd be interested in more hands-on, step-by-step tutorials for those topics. Otherwise, I hope you found this useful. I'll see you in the next one.